A 4,000-acre lake just outside Tallahassee, Florida, has disappeared. Not flooded, not polluted, drained through a single 28-foot hole at the bottom of its own basin into an underground river system running 19 miles beneath a pine forest. 12 billion gallons of water, gone in months. The lakebed is cracked mud and stranded lily pads. People are now walking down inside the sinkhole to hunt for fossils on rocks that normally sit under 20 feet of water. The lake has been doing this for centuries. The native Muscogee called it Okeeheepkee, disappearing waters, because they knew it vanished. It used to happen roughly once every 20 years. Since the late 1990s, it has drained 6 times. The 2025 drain is hitting during the worst drought in Tallahassee's recorded history, while every Florida water management district is simultaneously under a shortage warning for the first time ever. A 2018 tracer dye study confirmed where the water goes. 19 miles south through the Floridan aquifer, resurfacing at Wakulla Spring 35 days later. That spring and the aquifer feeding it supply drinking water to nearly 400,000 people. The lake is not losing water. The system it belongs to is under more stress than it has ever recorded. And Lake Jackson is the part of that system you can actually see. In May 2025, Lake Jackson is a basin of cracked mud. Lily pads are stranded in isolated puddles. Porter Sink, a 28-foot deep cavernous sinkhole in the southern lake bed, sits open to the sky. 2 men, Matt Lisby and Michael Surs, were photographed by the Tallahassee Democrat on May 4th standing inside it, hunting for fossils on rocks that normally sit under more than 20 feet of lake water. A bobcat was photographed crossing a concrete boat ramp. Birders who used to track waterfowl on open water are now tracking shorebirds on cracked sediment. Boat ramps at Falk Drive Landing end in dried mud. At adjacent Cascade Lake, cypress trees stand fully exposed with a sharp band of pale bark 10 feet up their trunks, the waterline from a year ago, still visible on the bark. This is not the first time dry downs have produced unexpected discoveries. During a 2012 drain event, a man on an ATV in the Porter Sink area reported finding skeletal remains to Leon County Sheriff's deputies. Investigators worked the scene before scientists, anglers, and curious residents arrived the following morning. The exposed lakebed has a history of surfacing things that the water normally keeps covered: fossils, bones, and artifacts from centuries of human use of the basin. The lake's periodic absences are also archival events. 12 billion gallons have drained since Thanksgiving week of 2025. Not removed by pumps, not consumed by evaporation alone, not diverted by any human engineering decision. Drained through one natural hole into the underground system below. The drain began when the sediment plug sealing Porter Sink gave way. Photographed by WFSU ecology producer Rob Diaz de Villegas at sunset on November 30th. Water cascading down into the opening. By December 2nd, the 28-foot sinkhole was fully exposed. A brief rainstorm in early December refilled it for less than 2 weeks. By January 6th, it was drained again. By March, vegetation was sprouting across the lakebed floor. By April 20th, when the Tallahassee Democrat sent a photographer out, the paper described the lake as almost completely dried up. Fish populations have compressed into the remaining deep pools: bluegill, largemouth bass, and gar circling in shrinking water at Church Cove and McInnes Arm. The Florida Fish and Wildlife Conservation Commission's biologist Chris Paxton notes that the eventual refill will benefit the lake ecosystem. That long-term framing offers little to homeowners watching the view from their docks turn from open water to cracked clay, or to anglers whose launch ramps now end in mud. This is not a malfunction. It is the lake operating as it always has. To understand what that means requires understanding what Lake Jackson actually is, and what sits beneath it. Lake Jackson is a karst lake, a body of water sitting on dissolved limestone. The bedrock beneath it is porous calcium carbonate, not granite or clay. Slightly acidic rainwater percolating through soil dissolves limestone over thousands of years, carving channels, caves, and cavities into the rock. The process that created the underground system below Lake Jackson began during the Eocene epoch, roughly 34 to 56 million years ago, when warm, shallow seas deposited thick layers of calcium carbonate across what is now the southeastern United States. As sea levels dropped and the limestone was exposed to fresh water, dissolution began. The result, accumulated over tens of millions of years, is the karst landscape visible today. a surface riddled with sinkholes, springs, and cavities, and a subsurface riddled with conduits connecting them. The lake occupies a 42-square-mile closed basin in northern Leon County. No rivers flow in, no rivers flow out. It is entirely rain-fed. Two natural sinkholes sit in the lakebed floor: Porter Sink on the south end and Lime Sink on the north. Both are openings into the underground plumbing system below. Normally, they are sealed by clay, organic debris, and limestone rubble accumulating over time. When the plug holds, there is a lake. When it fails, the water drains down through the sinkhole until the plug reseals or the lake empties. The lake has no other option. There are no rivers to overflow into, no outlet channels to absorb excess. When the floor opens, the lake goes with it. Below the lake sits the Floridan Aquifer, one of the most extensive freshwater aquifer systems on Earth, stored in porous limestone beneath most of Florida, southern Georgia, Alabama, and South Carolina. The aquifer is not a single underground lake or a uniform reservoir. It is a three-dimensional network of pores, fractures, conduits, and cave passages dissolved into limestone over millions of years. Water moves through it at widely varying speeds, depending on whether it is traveling through tight pores, which can take decades, or through open conduits, which can carry water miles in weeks. The surface and the subsurface are directly connected through sinkholes, springs, and subterranean cave networks. What drains into Porter Sink does not disappear into rock. It enters a moving system with a confirmed destination. In 2018, a team led by Dr. Sean McGlynn of McGlynn Laboratories poured fluorescent tracer dye into Porter Sink during a previous drain event. The dye traveled 30.6 kilometers south through the upper Floridan aquifer at an average speed of 0.87 kilometers per day. It emerged at Wakulla Spring 35 days later. Wakulla Spring is a first-magnitude spring, one of the highest discharge springs on the planet, averaging 250 million gallons per day, and it feeds the Wakulla River, which flows into the Gulf of Mexico. It is also on Florida's impaired waters list due to elevated nitrate levels, nutrient runoff from agriculture and development, and recurring algae blooms that have been worsening since the 1980s. The cave system connecting Wakulla Spring to the aquifer is one of the longest explored underwater cave systems in the world. The Woodville Karst Plain Project has mapped more than 35 kilometers of submerged passage beneath the Wakulla-Leon County area. Lake Jackson's water is traveling through that system right now. The Floridan Aquifer is the primary drinking water source for roughly 400,000 people in the Tallahassee metropolitan area. It also supplies agriculture across North Florida and South Georgia, feeds hundreds of first and second magnitude springs that define the ecology of Florida's river systems, and provides the baseline flow for rivers that drain into coastal estuaries supporting commercial fisheries. When Lake Jackson drains, it is feeding the same underground reservoir that supplies taps, wells, and irrigation across a multi-state region. The lake, the aquifer, the spring, and the municipal water system are not separate concerns. They are sequential stages of one hydraulic system operating entirely underground, invisible to the people whose daily water supply depends on it. The indigenous Muscogee people who lived in this region for thousands of years named the lake Okeeheepkee, disappearing waters. The name is a historical record. The Vanishing Act is not new. When Hernando de Soto's expedition wintered in present-day Tallahassee in 1539, Spanish chroniclers described the landscape as a savanna and big plain. No lake is mentioned. A British trader who worked North Florida in the 1740s also left no record of a lake in this location. That pattern across two independent historical sources from different centuries suggests Lake Jackson was absent or drained on both occasions. The same condition visible today. The first documented Euro-American observation of a drain event came in 1829. Additional events followed in 1836, 1886, 1907, 1932, 1957, and 1982. Roughly one drain every 20 to 25 years. The pattern was stable enough that each new generation of residents would experience it once, possibly twice in a lifetime. The Florida DEP notes that the periodic dry down carries ecological value. It resets invasive aquatic vegetation, exposes organic sediment that oxidizes and compacts back towards sand bottom, and temporarily creates wet prairie habitat. The lake's average of more than 20 plant species per square meter in exposed sediment zones reflects the diversity that these periodic resets support. The cycle was not a flaw in the system. It was a feature the ecology had organized around over centuries. Then the interval compressed. Since the late 1990s, the lake has drained in 1999, 2001, 2006, 2012, 2021, and 2025, 6 events in 26 years, compared to 6 events in the preceding 150. The gap between events has shrunk from roughly 20 years to as few as 2. The 1999 drain alone removed more than 4.4 billion gallons and reduced the lake to fewer than 500 acres. The 2025 drain is occurring against a lower baseline, a lake already depleted by months of drought before the plug failed. No peer-reviewed study has confirmed what is driving the acceleration. Several mechanisms are under consideration. Increased groundwater pumping across the region, from municipal supply for a growing Tallahassee metropolitan area from agricultural irrigation, and from industrial demand, lowers the water table in the Floridan aquifer. Under normal water table conditions, upward hydraulic pressure from the aquifer helps keep sediment compacted and stable in Porter and Lime sinks. When the water table drops, that upward pressure decreases. The sediment plugs lose structural support and become more vulnerable to failure during sustained drought conditions. Changing rainfall patterns may amplify the effect. Florida's precipitation now features longer dry periods interrupted by shorter, more intense wet events. The lake depends entirely on rain. No rivers feed it. If rain arrives less consistently, the plugs may not remain buried under stable water pressure long enough to fully consolidate. Sediment that would normally compact into a reliable seal stays loose and vulnerable. Accelerated limestone dissolution is another candidate. Slightly more acidic water from agricultural runoff, atmospheric carbon dioxide, or organic decomposition products dissolves calcium carbonate faster, expanding the cavities below the plug interface and reducing the structural integrity of the seal. Development and altered drainage around the lake may have changed how much clay and organic material reaches the sinkholes between events, reducing the raw material available to rebuild the plug. None of these mechanisms has been isolated or confirmed as the primary driver. Harley Means, Florida state geologist with the Florida Geological Survey, has noted that the drain frequency appears correlated with regional drought conditions. The lake drains more often during extended dry periods, but the underlying cause of why the plugs are failing more readily than they did a century ago remains an open question in the published literature. The 2025 drain is colliding with regional water conditions that have no precedent in the historical record. The National Weather Service classified the Tallahassee area under extreme drought, the highest severity designation on the U.S. Drought Monitor Scale. The Northwest Florida Water Management District issued a water shortage warning order, only the third in the district's history. The previous 2 were in 2002 and 2007. All 5 Florida water management districts are simultaneously under shortage warnings. That has never happened before. The Floridan aquifer is being drawn down across the state during this drought. Municipal wells pump harder. Agricultural irrigation increases to compensate for reduced rainfall. The aquifer recharges slowly through rainfall percolating through soils and limestone, a process measured in months to years for shallow recharge, decades for deeper zones. When drought reduces recharge while demand holds or increases, the water table drops across the entire system. Sinkholes that were stable under normal water pressure become structurally vulnerable. Springs that discharged year-round begin to slow. The Lake Jackson drain is one visible consequence among many operating simultaneously across the state. Porter's Sink will eventually reseal. Sediment and organic debris will gradually clog the opening, and when consistent rainfall returns, the lake will refill. Dr. Sean McGlynn of the Florida Geological Survey was direct about the refill requirement. Half-inch showers evaporate before the next one arrives. The lake needs sustained storms delivering 3 to 6 inches over weeks or months. Geologists estimate up to 15 million gallons per day can drain through Porter Sink when it is fully open. Refilling 12 billion gallons at a realistic rainfall rate requires sustained precipitation at a volume that isolated showers cannot provide. A single Atlantic hurricane making landfall near Tallahassee could dump 10 to 20 inches in 48 hours and refill the basin in days. Without that, the lakebed will remain exposed through the summer. Grasses and early successional shrubs are already colonizing the floor. If the dry down extends long enough, the basin could support a young forest before the next refill drowns it. The ecological system is adapted to this variability. Fish populations crash during dry downs and recover rapidly when the lake refills from eggs and juveniles surviving in residual pools. Bird communities shift between waterfowl and shorebird assemblages with each cycle. But those ecological adaptations were calibrated to a 20-year interval. At the current frequency, cycling every 2 to 5 years, species that require stable habitat during critical breeding or feeding periods may not recover fully before the next drain event begins. The 1999 drain reduced the lake to fewer than 500 acres. The 2025 drain is occurring on a lake already depleted by drought, with less residual habitat buffer for the species compressed into its remaining pools. Lake Jackson is one visible feature in an underground system that extends across most of Florida. The same aquifer, the same limestone, the same sinkhole mechanics that drain Lake Jackson are operating beneath thousands of other locations. Most are not visible. Springs that used to flow year-round go dry seasonally. Wetlands that held water through summer crack and harden by June. Sinkholes open under roads, homes, and farmland with increasing frequency across the state. Florida leads the United States in sinkhole insurance claims, and the frequency of reported sinkholes has increased as development and water withdrawal expand across the karst landscape. What Lake Jackson shows is the surface expression of subsurface stress. When the water table drops and rainfall decreases, karst systems that were stable for decades begin behaving differently. Plugs that held for 20 years fail after 2. Springs that discharged year-round become intermittent. Wetlands that buffered floods and filtered runoff dry out. The infrastructure, ecology, and water policy, built around the assumption of generational cycles, is now operating against a system that may be cycling faster than those assumptions account for. The municipal wells supplying drinking water to 400,000 people in Tallahassee draw from the same Floridan aquifer that Lake Jackson is feeding, and the same aquifer the rest of the state is drawing down during this drought. Wakulla Spring, where Lake Jackson's water resurfaces, is already on the state's impaired waters list. The spring feeds the Wakulla River and the estuary system downstream that supports commercial and recreational fisheries. Dropping aquifer levels reduce spring discharge. Reduced discharge concentrates existing nutrient pollutants instead of diluting them. The cascade extends from the underground system to the surface water to the Gulf Coast. The acceleration in Lake Jackson's drain cycle may be a temporary response to an unusually severe drought, anomalous conditions that will normalize when rainfall returns. Or it may reflect a directional shift in the regional water balance, driven by the combination of increased withdrawal, changed precipitation patterns, and accelerated dissolution. The data does not yet distinguish between those two possibilities. 6 drains in 26 years is the pattern so far. The next interval will carry more information than the current record can. State geologist Harley Means has described Lake Jackson as a checking account. When deposits exceed withdrawals, the account holds. When withdrawals exceed deposits, it drains. That accounting operates at the regional scale as well. The Floridan aquifer is the account. The entire state is making withdrawals. The 2025 drought is reducing deposits. Lake Jackson is showing the balance. The infrastructure built on top of this system was designed around the historical cycle. Water management policy, well permitting, drought response protocols, development setbacks, and agricultural irrigation rights. All of these were calibrated to aquifer behavior observed over the past century. If the system is shifting to a new baseline, those calibrations may no longer reflect the actual behavior of the aquifer. The Northwest Florida Water Management District's third ever shortage warning, issued in 2025, is a policy system catching up to a hydrological system that may have already changed. The lag between when a system begins behaving differently and when the policy framework responds to it is where damage accumulates. On May 4th, 2025, 2 men climbed down inside Porter Sink and walked across rocks that should have been under 20 feet of water. They were looking for fossils, remnants of animals that lived in and around this basin during previous dry periods, previous cycles of the same drain that is happening now. They found them. The lake has been emptying and refilling for longer than any written record covers. The Muscogee named it for disappearing because they watched it disappear, then watched it come back. It always came back. The mechanism has not changed. The plug failed. The water drained south through 19 miles of limestone, and Wakula Spring is delivering it to the surface right now. The same process the 2018 Tracer Dye study mapped. It's the same process that has been operating since before the first European set foot in North Florida. In that sense, Lake Jackson is functioning exactly as it always has. What has changed is the interval and the context. 6 events in 26 years instead of 6 in 150. A drought severe enough to trigger simultaneous shortage warnings across every water management district in the state. An aquifer is being drawn down faster than rainfall can recharge it. A spring already impaired, receiving one of the largest drain events in recent memory. The fossil hunters standing in Porter Sink today are standing on the same geology as everyone who stood there before them. With them, the geology is unchanged, the conditions around it are not. Whether the acceleration continues, stabilizes, or reverses will not be determined by a single drought year. The data accumulates one dry down at a time, and the next interval is the next data point.